People say, Sindre, you're so good in Excel, so what's your secret? Well, there's two things really. Number one, I stay away from the computer science guys. It's easy to be considered smart when you stay in a small duck pond. And number two, the secret behind my Excel success is that I'm profoundly stupid. When I was in university, I learned about things such as game theory. For instance, I learned about the Colonel Blotto game, and being so limited in my cognition, I just didn't get it. The professor was giving one single example, and that was not enough for me to understand how it works. So what I did, I used my computer, which had very limited user rights. So the only thing I could really program in there was Excel. So I sat down and I tried to program Excel with Visual Basic Applications. I tried to program it to play Colonel Blotto game with me, so that I could more finally understand what is going on inside of it. And the thing is, when you try to do silly things like that, you start to learn a lot about the software. You start to learn a lot about Excel and VBA. So that's essentially the secret. When I didn't understand something in the lectures, I tried to do it in Excel. So that's the secret. So I was thinking in this video we can look at how I did it, how I got Excel to play Colonel Blotto with me. Yes, I think it's quite interesting. So let us just start by going through the details here of what exactly Colonel Blotto is. In Colonel Blotto, there are two players who plays a single round where they have an equal number of resources that they have to allocate across a given number of battlefields. The players make their moves simultaneously, or their moves are revealed simultaneously at least. The player with the most resources on a battlefield wins the battlefield, and whoever wins more battlefields wins the entire game. So to further illustrate, let us consider an example where you have two players. They have 100 units each, and they need to allocate it across 3 doors or 3 battlefields. So let's see how that would work. As an example, player 1 could be playing 50, 40 and 10 on battlefield or door number 1, 2 and 3 respectively. And player number 2 could be playing 33, 34 and 33 on these 3 battlefields respectively. So what happened here is that player number 1 will win door number 1, battlefield number 1, because 50 is greater than 33. Likewise, player number 1 will win door number 2 because 40 is greater than 34. But player number 1 will be losing door number 3 or battlefield number 3 because 10 is less than 33. However, since player 1 has won the door number 1 and 2, this player will win the entire game. Here we are in the Excel spreadsheet, and I've already done the job. This is what it looks like. Let me just show you what's going on here. So we have the opponent, and the computer here is going to pick some numbers, and I'm going to pick my own numbers. So I already picked mine, 33, 34 and 33, so we can just click play here. And as you can see, the computer, it doesn't know what I picked. You just have to trust me on that. We can look at the source code later on and see that that's the case. But the computer picked 44 for door number 1. That is greater than my 33, so the computer is gonna win the first door. So I'm losing here, the first door. On the second door, the computer picked 18. I have 34, that is more, so I win the second door. But for door number 3, the computer picked 38. I have 33, so I lose. So I have 2 losses, therefore the opponent wins the entire game. So let me just show exactly here what is just hard-coded in the worksheet and what is generated by the VBA code. So I have just written here in the worksheet, winner column, made it bold. That is just me writing it in here in the worksheet. The script is not going to generate this for you. Same with you or the player or us. Opponent, door number 1, 2 and 3. So that is hard-coded, and my allocation is also hard-coded. So there are 4 more cells here, which has a function inside of it, so that is also kind of hard-coded here in the worksheet. So this is just the sum of C3, D3, and E3, and this is the sum of C4, D4, and E4, and that is just to help me to make sure that I'm using all my resources and that I'm not overspending my resources. So if I have exactly 100 allocated units, cell G4 is not going to say anything. If I, for instance, have less, it's going to tell me, hey, you have unallocated resources. I only spend 76. However, if I overspend 106, for instance, it's going to say cheater. You're spending too much. So it's a pretty simple nested if function here. If the sum is equal to 100, then nothing. Otherwise, it's an odd if function. If the sum is less than 100, it's going to say unallocated resources. Otherwise, which will mean that is more, it's going to say cheater. So pretty straightforward. So what is going on here with in terms of the computer generating an allocation and then seeing who is winning? We can click Alt F11 here in order to open up the VBA script. Here it is. It's a subroutine, and I call it Colonel Blotto _play because we have 2 buttons here, clear and play. Let me open that again. So the first order of business is to generate an allocation for the computer. And the way to do that is to kind of scale the output of this pseudo-random number generator, accessed using the Wishman-Hill algorithm. And the way to scale that is to apply the, I think this is the floor function. So I have a whole video to explain how to generate pseudo-random numbers that are discrete and uniform. It is over here or over there. I recommend you to take a look at that if you don't know how to do that. It's too much details for me to go through it. But essentially, I'm going to have to draw 2 different pseudo-random numbers that are uniform and discrete. And then the third one is just going to be the residual. So first, I specify a minimum and a max. The minimum is going to be 0 because we can always choose to have 0 allocated on the battlefield, but not less. The lowest allocation is 0. Then the highest allocation is 100. You cannot have more than 100 on one particular door. So I generate a pseudo-random number, discrete and uniform, that is going to be from 0 to 100. So that is what's going on over here. I generate a number from 0 to 100. But if I generate 100 for door number 1, I cannot have anything on door number 2 and number 3. So when I generate a second pseudo-random number here, I need to take into consideration the first one I generated. So for the second draw, I re-specify the maximum number that I can draw. And that is going to be 100 minus whatever I generated for the first door. So that's what's going on here. Draw number 2 underscore max is going to be equal to draw number 1 underscore max, which is specified up here, that's just 100, minus the pseudo-random number I generated over here. So if I generated for draw number 1 60, for instance, well, then I can maximum have 40 for draw number 2. So I'm generating there a number from 0 to 40, or whatever the first draw is. And for draw number 3, well, that's just going to be the residual of whatever is left. So if you go back here to the worksheet, let's see if we can play a few times. So you see it's always going to be 100, 98. Draw number 1 was like 98. Well, then it's only 2 left. So then it's gonna, for second draw, generate a pseudo number that's either gonna be 0, 1, or 2. In this case, it turns out to be 1. So then the residual is just going to be 1. So sum is going to be equal to 100 no matter what. So you can click a few more times here and see it's always going to be the case. So that is how I generate this allocation. But there is one big issue with the way I'm doing this. This is due to the limitations of my programming skills because I don't have a background in computer science. I'm sure there's a better way to do this. But the problem here is that it's not going to generate or select all possible allocations with equal probability. This script will be able to generate all possible allocations, but not with equal probability, I think. So the expectation here is that when you draw a random number from 0 to 100, on average it's going to be 50. That means on the second draw it needs to generate from, on average, from 0 to 50, so the expectation would be 25, and the residual would be 25. So I expect the allocation that the computer generates to be this: 50, 25, 25. This means I have a huge unfair advantage. My strategy will essentially be to always ignore door number 1, and then just split it equally here on door number 2 and 3. I'm not gonna always win like this, but I'm gonna win. I'm gonna have an advantage here. I'm gonna win more than my fair share. So I have unfair advantage here. I have some insight in how the computer is thinking. So to combat that, I am kind of putting like a band-aid here. So what I do, I'm going to or generate these 3 numbers, but I'm gonna shuffle them around. I'm not necessarily gonna put the first draw on door number 1 and draw number 2 on door number 2 and draw 3 on door number 3. I'm gonna shuffle it around. So that is what is happening here. I generate a pseudo-random number between 0 and 1 called u using R&D syntax. That is just the Richmond-Hill algorithm. So if u is less than 1 divided by 6, then I'm gonna do a certain allocation. If it's between 1 over 6 and 2 over 6, I'm going to do another allocation, and so on and so forth. Why 6 times? Because there are 6 possible ways to shuffle around 3 doors. It's going to be 3 times 2 times 1. So permutation here is going to be equal to 6. So I'm just shuffling it around there. Pretty straightforward. And the next here, I have basically 3 snippets of code which are pretty similar. So for door number 1, I'm going to explain it. And then for door number 2, again, basically the same script. The only thing that's changing here is which cell I'm looking at. And then door number 3. So what I'm doing here, I am going to check, okay, let's clear it and play. I'm going to compare the numbers. If opponent's number is less than my number, then I'm going to write here win, and I'm going to color it green. If that is not the case, then I'm going to say here lose and color it red. So how am I accomplishing that? Let's look at door number 1 here. So I could write here hard code the cells I'm looking at, but I made it a little bit more dynamically. So I can just very easily just change like 2 lines of code up here. But let's look at it. So if range, my call and my row, so that's going to be C3. So if C3 is less than 1 row below, so if C3 is less than C4, then what's going to happen? Well, then I'm going to put out in C5 over here. I'm going to write in there win, and I'm going to color it green. So this code right here will color the cell green. And this snippet of code here, I really don't know how to write this myself from scratch. So the way I'm doing it is to use on the developer tab here and go to record macro. Then I just click record macro, and I just color one cell green, for instance, or red. And Excel is generating the VBA code that is like coloring a cell green and red. So that's how you can do that. I have another video explaining how that works. You can look at that. So this is if condition. So if opponent's resources is less than my resources, then I win. That's what's happening here. If that's not the case, well, then we're going to do something else. Then instead we're going to write here that in C5 that I lose, and we're going to color it red rather than green. So pretty straightforward. Then I just copy paste this whole segment of code down here. The only thing that's changed here is that we're now looking at the D column. Up here we're looking at the C column. Now we look at the D column. So straightforward. And then exactly the same code again for door number 3. The only thing that's changed is that we're now looking at the E column. And one final thing here is that we need to see who won the game. So for each of the doors, I'm just keeping track of the score, my score. So I start here by saying points equals 0. If I win on door number 1, then I'm going to increment my score by 1. So points equals points plus 1. So it was for 0, then it becomes 1 if I win door number 1. And then on door number 2, if I win that, then I add another point. And on door number 3, I add another point if I win. If I don't win, well, then I don't add a point. Let's see, but actually, no, I don't remember code. It seems I did exactly the opposite there. I'm keeping track of the opponent's score, I think. Yeah, so I'm keeping track of the opponent's score. So the game winner. So sorry, I said completely wrong. I'm keeping track of how many doors the computer is winning, not how many I win. So if the computer's score is less than 2, well, then the player is going to win. So then I will write down here player, and I'm going to color it in green. So that's what's happening here. So if the points accumulated by the computer is less than 2, then in cell C7, it seems, I'm going to write player, and I'm going to color that cell green. Otherwise, if that is not true, then I write opponent, and I color it red. And then finally, I just go to cell C4, which is where I put in my my allocation up here. So that was a little bit messy. So let's play one more time and just try to explain it. We do an allocation, 3 cells here. Then we check each door and color lose or call it red or green and say win or lose depending on the wins. We do it 3 times. And then finally here we color it red and write opponent if I lost, and color it green and write player if I won. So that is how it works. Got a little bit confusing there, always a little bit difficult to explain. So I think what I'm going to do now is just to scroll through this code slowly so you can just see it for yourself. So here's the entire code. It's not as intimidating as it looks like. It's if you know how to use the macro recorder, if you know how to generate pseudo-random numbers that are discrete and uniform, and if you know if then else, then that's basically it. That's all you really needed to know in order to write this script. So that is the code. But there's one more here. I have a clear button. If I click clear, so what is that doing? It is basically just going to erase what's written here, and here, and here, and here, and here, and it will also just color these cells to be blank again. That is what the script is doing. So over here, I'm not going to explain this too much for you. So see, it just looks at a particular range and it clears the content. And then it just removes the background color there. That's basically it. It's pretty straightforward. So this code, I think you should be able to understand on your own. So yeah, that's how you do Colonel Blotto in Excel. So just trying to do these sort of things. It's not a really difficult task, but you will be surprised if you start doing like really small, simple things like this. As time passes on, you are actually going to end up knowing quite a lot about how to do Visual Basic Applications programming in Excel. And eventually, before you know it, suddenly people are going to be, hey, how did you get so good in Excel? So yeah, that's my story. See you around.